Students, today we are going to study shift register. Okay. At first, we have to understand what is register, how we can store bit in register. What is register? Register is a circuit IC chip which is used to store data in computer memory. It is a temporary storage area. I think we have already know it in class 11. Okay. Now I have to know today the functioning of register, how bits can be stored in a register. Okay, we have already studied about flip-flop. What is flip-flop? It is used to store one bit information. So we have already studied SR flip-flop, D flip-flop, T flip-flop and JK flip-flop. These all flip-flop are used to store. You know that there is one state storage. So this is the So all flip-flop are used to store one bit information. So if we store one bit information, it is required to one flip-flop. So if we want two bits information means suppose we store 1 0. So in order to store 0, we need one flip-flop, and in order to store 1, we need another flip-flop. So for 2 bit information, we need two flip-flop. Okay. Now for 3-bit information, we need 3 flip-flop. How? Suppose we want to store 101. Okay, so 101, in order to store 1, we have need one flip-flop. In order to store 0, we have another flip-flop. In order to store 1, we have another flip-flop. So we need 3 flip-flop. So like this way, if we need to store n bit, n means if we want to store 8 bits, we need 8 bits flip-flop. If we want to store 16 bit, we need 16 flip-flop. So if we want n bits, we need n flip-flop. This is the basic concept. Okay, how if number of bits determine the number of flip-flop in a register. So the register which is used to store 16 bit data, then that register use 16 flip-flop. Individual 16 flip-flop. Mind it. Individual 16 flip-flop means they are used 16 SR flip-flop either, or 16 D flip-flop, or 16 T flip-flop, or 16 JK flip-flop. Okay, anyone which we required according to our configuration in the register. Okay, so group of bits means group of flip-flop. So group of flip-flop collectively creates one register. Okay, so the series of flip-flop creates one register. So in one statement we can say register is a group of flip-flop that store group of bits. Temporary storage area, we know that the storage of a flip-flop changes according to the clock pulse. So register also is temporary storage area. In general, we use to store D flip-flop. In general, we use D flip-flop to store data in the register. Why D flip is used? We know that in D flip-flop, all of you have the truth table of D flip-flop. Here I also draw it, and you can see it in your copy, that if the input is 0, then output is 0, input is 1, output is 1. This is the main criteria of D flip-flop. For that reason, D flip-flop is used to store data. Whenever we give 0 input, it gives output 0. It's not change. Okay, whenever we give 0, it gives 1 output and vice versa. No, that's not. If we give 0, it gives output 0. If we give 1, it gives output 1. So it's very simple to store data using D flip-flop. For that reason, in general, storage register or data register is used in use D flip-flop. Okay. Now this is the diagram of D flip-flop. We have to mention one thing here is it is every D flip-flop works on positive edge clock pulse, either on negative edge clock pulse. Positive edge clock pulse means positive edge triggering. We have already studied positive edge triggering means when the clock pulse changes from 0 to 1. It is positive edge triggering, and you see that in positive edge triggering clock pulse only one arrow is given in the clock pulse. Okay. In negative edge triggering there gives one circle behind the arrow sign. Okay, this shows negative edge triggering of clock, this shows positive edge triggering of clock. In order to distinguish, I draw here the two clock pulse to understand, so that you can understand. So positive edge triggering means this device works whenever clock changes from 0 to 1. Okay, and negative edge triggering means we have already studied positive and negative edge triggering. I think it is clear to you. Negative edge triggering means when the clock changes from 1 to 0 in downward direction, and positive edge means in clock upward direction. Okay, it does not matter whichever clock pulse we can give. Okay, so if in the diagram it's drawn like this with a circle in the clock pulse, it shows negative edge triggering, and if it's there is no clock a circle in the clock pulse, it is positive edge triggering. Okay, so D flip flop is used in shift register, and the number of flip flop determines the number of bits stored in the shift register. Okay, so the what is shift register? Shift register is kept register is used to store the data. Now what is shift register? What is the meaning of shift register? Register two type, either it can store data or it can shift data. Shift data means it can shift the data from one flip flop to another flip flop. Okay, that is the shift register. So a register of capable of shifting bits of information from left to right or right to left is known as shift register. Okay, so as a register is a combination of flip-flop, so if the data moves from one flip-flop to another flip-flop, if it is possible to move the data from one flip-flop to another flip-flop, it is known as shift register. Okay, suppose this is the main general configuration, so that you can understand okay, how data can be moved. Here it's see we store 4-bit, creates a 4-bit register. Okay, 4-bit register means we need 4 flip-flop. You see here, this is flip-flop 1, flip-flop 2, flip-flop 3, flip-flop 4, and all are D flip-flop. To D flip-flop means every flip-flop had input. You see here, this is input D3 for first flip-flop, D2 second flip-flop, D1 third flip-flop, D0 fourth flip-flop. Okay, this is input. Every flip-flop has one input and one output. We have seen, you see, like this way. Here it is drawn. This flip-flop is drawn. D input, one clock input and one output. Okay. You see here, this is input, this is output Q3, and this is clock. For the first flip-flop, similarly, this is D2 input, Q2 output, clock, D1 input, Q1 output, clock, D0 input, Q0 input, clock. So for each flip-flop, there is one input, one output, and we don't write here the negative complementary output because we don't need it. Just we have to show this how it is configured in a register. Okay, and all the flip-flop are connected with the same clock pulse. You see here that all that this is there is a circle in every flip-flop, so that is negative edge triggering clock pulse is given in this flip-flop. Okay, and all the clock pulse is given for each flip-flop. Same clock pulse is given. You see there, same clock is goes to every flip-flop. Okay, so whenever clock is 1, every flip-flop gets 1 value and gets active. Whenever clock is 0, every flip-flop gets 0 value and gets is inactive. Okay, now again the output of first flip-flop is connected with the input of second flip-flop. Okay, here also Q2 connected with D1, Q1 connected with D0, and this is the last output. This is input and this is output, and all other flip-flops input goes from the previous output. Again mind it, here Q3 is connected with D2. That means the output of previous flip-flop goes in the as an input in the next flip-flop. Here Q2 is the output, so out Q2 is connected with D1. What does it mean? D1 is the input of a flip-flop 3. So output of previous flip-flop connected with input of this flip-flop. There is also this, and we get output from Q0. Now, according to shift register, as the output goes, so whenever we explain it later. Okay, this is the basic structure of flip-flop flip-flop in a shift register. Okay, now if we enter data D1 from D1, you see here on only one interface, we can enter data or retrieve data from the flip-flop. In order to store the data, we have to enter the data either in the flip-flop or we have to retrieve the data from the flip-flop. So in order to enter the data flip-flop, there are two processes. Serially means one by one data can be entered in the flip-flop. Okay, if it is 4-bit 1011, first it goes 1, then second 0, second 1, second 1. So it is serially one by one. So one by one means there is only single line and we enter the data like this way: 1 1 0 1 0 1 1. One single line and it goes like this way. Okay, suppose there is a single line and all the full members goes one by one. So this is serial enter. Okay, and in parallel enter there are 4 lines, 4 path. Okay, and for in every path we enter, suppose first path we go 1, second path we go 0, third 1, fourth 1. This is parallel enter. For parallel enter, for every bit there is an individual path, and for serial enter there is an one single path in order to go there. Okay, same way we can retrieve the data serially means we have one single path and we can retrieve the data one by one from that path, and parallel means there are 4 paths and we can retrieve all the data at a time. In parallel path, for each bit there are individual data and we get the data at a time, and for serial path we get one path and one by one data. So obviously serial path takes longer time than parallel path. Okay, according to this configuration, flip-flop is classified in 4 ways: serial in, serial out. That means in this type of flip-flop SISO, data are input serially and data retrieved serially. Serial in, parallel out, data are input in serially and retrieved in parallelly. Parallel in, parallel out, data input serially, retrieved in parallelly. Parallel in, parallel out, it's also serial and retrieve, both are in parallel way. And parallel in, serial out, data inputs in serially and outputs in parallelly. Now we are going to study this 4 type of flip-flop shift register one by one.